Let's do some math for fun. Here we are going to integrate x squared over parentheses with x times sine x plus cosine x and then square. Yes, this seems really impossible, but yes, this is in fact doable. Therefore, please pause the video and try this first. Okay, hopefully you guys have a chance to try this. And before I show you guys how I solve this, I would like to just ask you guys to subscribe if you haven't done so already. Anyway, I noticed that in the denominator, we have this to the second power, right? So it kind of reminds me of a quotient rule situation, because when you differentiate a quotient, you will have to do the bottom square. So one of the ways to do this is that maybe I can just guess and check. A top function divided by perhaps the inside here will be the bottom function, and I'll just have to check the top and then just, as I said, guess and check, right? But because I know quotient and product is pretty much the same thing, therefore, to undo the quotient rule situation, I can also use integration by parts. Let me show you how we can do it. With that being said though, I need to pick one part of the integral to be integrated. But I certainly cannot integrate anything right here at the moment, right? I do want to know what the derivative of this right here is. So let's make some observation first. I would like to just figure out what the derivative of the inside first. So let's differentiate x times sine x. And notice just the inside, all right? I just want the inside derivative right here. And let's see. Here, we have to do the product rule. So the derivative of this is just you keep x and then times the derivative sine x, which is cosine x. And then you add it with sine x times the derivative of x, which is 1. And then the derivative of cosine x is minus sine x. And nicely enough, this and that cancel. And in fact, this right here is just x times cosine x. All right. If I can somehow come up with x times cosine x, then I can actually do a little u substitution to get the integral, right? But I don't have any, therefore I'm going to rewrite this integral. I will have to introduce the cosine x to help us out. So let me just write down the following. This is the same as the following integral. Well, this is what I really want to have. I want to have x times cosine x on the top, and then perhaps I will just keep the original denominator, which is the parentheses, and we have that x times sine x plus cosine x and then square, right? dx. And you see that if this is the integral, we can actually do it by doing u sub. Let u equal to the inside function, because now if you differentiate that u, you pretty much will have this, and then that's pretty much that, so you can integrate that, right? However, this is not the same as the original integral, but we can be smart. Well, first of all, we see that originally I have x squared. Now I only have x to the first power on the top. So I will just need to multiply by x right here. And originally I didn't have cosine x. Now I do. I just have to divide it by the cosine x. So I will just put this down right here. And as you can see, this right here, if you look at this x in black as well, x times x is the x squared, and the cosine x will cancel. So this is the same as the original. And the purpose of doing this is that we can proceed with integration by parts. I would like to integrate this part, and then I would like to differentiate this part. And you see, this is why I don't teach my students the Inequality method, because it's the memorization, and then that doesn't force you to think. This kind of things, it does force you to think, right? Anyway, I will of course use the DI format, like why not? And I will put it down right here. We have the D and then the I, and let's put down a plus minus on the side to get ready. And once again, we will be integrating this part. So right here we will have x times cosine x over parentheses x times sine x plus cosine x and then square on the bottom like this. And then we will be differentiating that, which is just x over cosine x like that. Okay, so we see that to integrate this, I can just do a simple u substitution, that u equal to the inside, and then du will be this times dx, which is the top. In another word, we're trying to integrate 1 over u squared. And when you integrate this, the answer to that is negative 1 over u. And u is the inside, so I will just write this down as negative 1 over x times sine x plus cosine x, like this, right? So that's pretty much it. And if you differentiate this, you will get that back, so you can try this on your own. And then I will have to differentiate this, and of course we will have to use the quotient rule. Therefore, I'm going to square the denominator, so that's cosine square x. And then the top is, we will do the bottom function, which is cosine x, times the derivative of the top, which is 1. And then minus the top function, which is x, and times the derivative of the bottom, which is negative sine x. And be careful, this is negative times negative, so in the end, on the top is just cosine x plus x times sine x. All right? And now you see, the beauty of this is that this and that are the same. And remember, this row is actually an integral, right? When you multiply that row, you still have to put that in the integral. And we can totally integrate the rest. So we are going to stop right here. And we see that here is the first part of the answer, which is this times that. So I will just do this for you guys. And be sure you account for the sign. We have positive times this is negative, so all in all is negative. And we have the x on the top, so let me just write this down. Negative x over this times that, so I'll just put on cosine x times sine x plus cosine x, like this. That's the first part of the answer. And then the second part of the answer is that I will do the product of this row. And remember, it's a product of a row, so when you do this times that, in fact, they cancel each other out because they are the same. The order of addition doesn't matter, right? So this is really nice. And you see, we have negative times negative, so we add the integral. And by the way, this negative and this negative right here turned out to be that plus already, so I took care of that already. And this was my 1. So just to make it clear. Okay, so what's left? Well, I took care of the sine already. Now we just have the cosine square in the denominator. So this is just 1 over cosine square x. And of course, this right here is just the same as saying the integral of 1. Well, 1 over cosine square is secant square x dx. So this is nothing but just tangent x. So I can write down the answer. This is negative x over cosine x times sine x plus cosine x. And then this right here, we add it with the answer for that is just tangent x, right? And I know I'm done, I can put on plus c, but I know some of you guys, in fact, many of you guys perhaps did that on Wolfram Alpha already. And if you did that, you know this is not the answer that we present, so I will do more. Tangent x, it's of course the same as sine x over cosine x, so we'll continue from there. And the way to take care of this is that, of course, we just combine the fractions. Let's get a common denominator. I need this guy to help me out, right here. So I multiply by x times sine x plus cosine x on the bottom and also on the top. And then we proceed. Both of them have the same denominator already, so I will just put this all over that denominator, which is cosine x times sine x plus cosine x, like that. And then this right here is negative x. That's good. And of course, you can draw little arrows to make you happy. Doesn't matter anyway. Anyway, just to multiply this, right? So here we have what? This times that. That's going to be positive. And we have x times sine x, which is sine square x. And then we have sine x times that, which is plus sine x times cosine x, like that. All right, so this is good, but not good enough. Because once again, this is not the answer on Wolfram Alpha. And perhaps we see that we do have the sine square x right here. Let's change that to what? 1 minus cosine square x. Maybe it works, maybe not, I don't know. Just give it a try. I will distribute that right here. So let's see. when you distribute, just get x, right? And then that's going to be x times cosine square x, right? And the reason I want to do that is I noticed I have the negative x and the positive x that cancel each other out. So that's pretty nice. And now what? Here I have minus x times cosine square x plus sine x times cosine x. Both of them have cosine x, so of course I can factor that out. So let me factor out the cosine x. And then here is negative x times another cosine x, and then we add it with sine x over that for the denominator, so cosine x, and you see they are going to cancel each other in a second or so. Cancel them out, yeah? And we are done. This is the answer, all right? So I will just write this down legitimately. Finally, we see that the answer is this, which is negative x times cosine x plus, and with that, we are done. So let me just put a plus c right here, and that's it. Okay? And perhaps the question is that who came up with this question in the first place? It's actually pretty easy. You just start with a quotient, you differentiate that, and if you see a lot of simplifications, that will make the integral really, really hard. So if you start with this, do the derivative, and you can simplify it to this, and then you can ask somebody to integrate this for you. Anyway, do you guys think that I should put this on my Calculus 2 exam? Leave a comment down below.